Hello, in this lesson we're going to look at how to find the equation of a circle where the centre is a given point, we'll call that AB, and the radius has length r. So in my previous lesson we looked at how to find the equation of a circle where the centre was the origin. That's really just a special case of what we're going to do today, which is how to find the equation of any circle. So what we'll do in a similar way to the previous lesson is we'll look at this right angled triangle that we create between the point P on the circumference and the centre of the circle. And we'll see this time that applying the distance formula here, the horizontal distance will be x minus a, and the vertical will be y minus b. So that's really just your previous knowledge of straight lines. What that means here is that for this right angled triangle, we can tie together all these variables again and say that x minus a all squared plus y minus b all squared must equal the radius squared. This is just Pythagoras' theorem. And that's actually the equation of any circle where we can input a centre AB and we can have a radius of length r. Now what I would recommend you do here is use a graphing package. One I recommend would be Desmos, although there are other options available, and just play with that equation. If you type that equation in, you'll be able to add a slider, you'll be able to change the values for a and b, and r, and you'll get various circles, and you'll see how that's affecting our previous model. But we'll look at some examples in this lesson of how we apply this to higher mathematics. So let's just look at one example, although there are three problems here, of how to apply this equation to a problem where we have the centre and the radius. So if we look at the equation that we discussed, x minus a all squared plus y minus b all squared equals r squared. For the first problem here, we can apply that by inputting a and b. So the equation would be x minus 2 all squared plus y, take away 5 all squared, must equal 4 squared. And of course, the equation then is x minus 2 all squared plus y minus 5 all squared equals 16. There is a question about whether we break these brackets or not. We'll discuss that in the third lesson in this series. So at the moment, that's the equation that we want. For part B, we need to be a bit more careful. We notice now that x take away -1 is what we're going to input, all squared. We'll leave that for a moment. And y take away 6 all squared, and that must equal the square root of 2 squared. So we can see now we've got a double negative, which means actually the equation here is x plus 1 all squared plus y take away 6 all squared equals, and square root 2 squared is just 2. So be careful with the double negative. That's going to be a feature of the questions that you tried today. For part C, something else to watch out for: if the centre has an x or y coordinate which is 0, well, we can substitute that in first of all. X minus 0 all squared plus y minus -3 all squared must equal 2 root 5 all squared. So clearly x take away 0 is just x. What we're going to do here is just write that as x squared plus y plus 3 all squared, and that will equal, well, 2 root 5 squared. You need to be very good at your surds in this particular topic in higher maths. 2 root 5 times 2 root 5 is just 20. So that's a circle with a centre 0, -3, radius 2 root 5. Again, using Desmos would be a good idea here to look at some of these graphs in a bit more detail. I suggest you do that. Good luck with your attempts on these questions. Okay, so that's the most important equation of the circle that we've now covered. It's time for you to get some practice with that equation. Here are the pages from the two textbooks you're most likely to be using, and I suggest you do all of the questions in these. And remember, this is now lesson 2 of 5, and if you want to continue, please check out the next lesson in the series.